Hi, welcome back. Inverses Day 2. Vocabulary today will be one-to-one and the horizontal line test. How do you tell if this graph is a function? At this point in time, the vertical line test should be our quick answer. The answer to this question is yes, because anywhere that I place a vertical line, it will pass the vertical line test. Describe what the horizontal line test is. We will use that to help us to determine if the following graphs have an inverse that is a function. So to determine that, we will simply draw our horizontal line to determine if the inverse will be a function. No, this is not. Yes. And no. Oh, sorry. Yes as well. The original is not a function, the inverse is. A one-to-one function is one where the inverse and the function itself are both in fact functions. In order to do this with the graph given, you simply draw your vertical and your horizontal line. If a graph passes both the vertical and the horizontal line test, then it is considered one-to-one. This one's a little bit tricky. It is a rational function. The rational function behaves in such a way that the graph will approach but not touch these lines right here, which are considered asymptotes. And because the graph will not touch them, this is considered a one-to-one relationship. More to come on this parent function in the future. Horizontal and vertical line test. To this question is no, not a one-to-one function. Please be able to recognize one-to-one functions graphically. Alright, how do we find the inverses algebraically? That is, switch x and y and solve for y. Alright. Some of these are pretty simple and pretty straightforward. Others need a little bit further explanation. So here we go. F of x equals 4x plus 5. I'm going to skip the step of changing f of x to y, and I will simply, for lack of space, switch automatically x and y. Subtract 5 to both sides. X minus 5 equals negative 4y. Divide by negative 4. And I get f of negative 1 of x equals negative 1/4 x plus 5 over 4. Alright, before we continue on this one, we must understand that there's a restriction. The restriction on the original function is x must be greater than or equal to 0. Please refer back to domain restrictions from earlier in the unit to recall that particular restriction. Now we will switch x and y. Square both sides. X squared equals 3y. Divide by 3. And f of negative 1 of x equals x squared over 3. X must be greater than or equal to 0. Please include your restriction. Number 7 and number 8 are identical. We will not go over number 8. Number 9. Again, we must recognize that there's a restriction in the original function. Please recall that x must be greater than or equal to negative 2. And now we will solve. X equals 5 plus the square root of y plus 2. Subtract 5 to both sides. X minus 5 equals the square root of y plus 2. Square both sides. And now we get x minus 5 squared equals y plus 2. Subtract 2 to both sides. X minus 5 squared minus 2 equals y. F of negative 1 of x equals x minus 5 squared minus 2. Please remember your restriction. X must be greater than or equal to negative 2. Alright, number 10. Because we did not complete number 8, I will utilize that space to fill in some of the work for number 10. So here we go. X equals 3y plus 2 squared. Divide both sides by 3. X divided by 3 equals y plus 2 squared. Square root both sides. The square root of x plus x divided by 3 equals y plus 2. It is at this point that we must recall that there is a restriction on this square root. However, there is no restriction on the original function, therefore we must include the plus and the minus. Whenever you square root both sides of an equation, you always get a plus or minus value. Alright, so to finish out the equation, subtract 2 to both sides, and we get y equals plus or minus the square root of x divided by 3 minus 2. F to the negative 1 of x equals plus or minus x over 3 minus 2. And number 11, I'll be moving down the page and expanding so that I have enough space to show you the steps without disruption. So I'll begin with x equals 5 plus the square root of 10 minus 2y divided by 3. Please recall that there will be a restriction in the domain, and that will be x must be greater than or equal to 5. Multiply both sides by 3. We get 3x equals 5 plus the square root of 10 minus 2y. Subtract 5 to both sides. 3x minus 5 equals the root 10 minus 2y. Square both sides. 3x minus 5 squared equals 10 minus 2y. Subtract 10 to both sides. 3x minus 5 squared minus 10 equals negative 2y. Divide both sides by negative 2. I will separate these out. It makes it simpler to divide out your 10 and 2. 3x minus 5 quantity squared divided by 2, and that entire thing will be negative, plus 5 equals y. F to the negative 1 of x equals negative 3x minus 5 quantity squared divided by 2, with the restriction that x must be greater than or equal to 5. Number 12. Alright, explain the meaning of the inverse of the function. But first we must explain the meaning of the original function. That is lateral area in terms of its height. That means that the height is independent and the lateral area is dependent. The inverse of the function is the height in terms of the lateral area. That means lateral area is independent and height is now dependent. To find the inverse of the function, we have to switch the x and y variables, which looks like this. 2.5 pi times h. Now we switch it. The independent and dependent values switch. So it's h of L equals 2.5 pi times L. That is the critical step in finding the inverse in terms of real life examples. Now we will solve for, we'll switch x and y, or switch the two variables. So it's a double switch in and of itself. So L equals 2.5 pi times h of L. Divide both sides by 2.5 pi. Divide both sides by 2.5 pi. So your inverse is h of L equals L divided by 2.5 pi. Plugging in the value, 35.4, h of L equals 35.434 divided by 2.5 pi. The answer is approximately 4.5 inches. Alright, number 13, finding the height. Okay, so again, what we must do is we must switch the variables. So that means it's going to be a of h equals 3 times the square root of h plus 19. Switch the independent and dependent variables. Now switch x and y. So it's going to be h equals 3 times the square root of a of h plus 19. Okay, erase this to give myself some room here, and we will solve this guy to the end. Subtract 19 to both sides. H minus 19 equals 3 times the square root of a of h. Divide by 3. H minus 19 divided by 3 equals square root of h of a. Square both sides, and you have your final equation, which is a of h equals h minus 19 divided by 3 quantity squared. Plug that in and you get approximately 20.25 inches.